To finish up our discussion of the SN2 reaction, let's take a look at the stereochemistry. During the SN2 reaction mechanism, the nucleophile will come in from the opposite side that the leaving group is leaving, and that's to minimize the steric repulsion between the electron-rich nucleophile and the electron-rich leaving group. Remember that the transition state looks something like this, and notice that the nucleophile and leaving group are on opposite sides. And then finally, once the new sigma bond is formed between the carbon and the nucleophile, you actually end up with an S configuration, even though we started out with an R configuration. So during an SN2 reaction, chiral centers are inverted. We do have to be careful, though, about using the term inversion to imply a change in configuration. So in other words, inversion does not mean that an R configuration goes to S or that S goes to R necessarily. Let's take a look at this example to illustrate that. We're starting off with a chiral center that has an R configuration, and you can see how I have the groups prioritized. If we bring in a nucleophile like CN-, based on the prioritization using that Kohn-Engold Prelog system, you still have an R configuration. The key thing is that the nucleophile came in from the opposite side that the leaving group left, and that's what's meant by inversion, not necessarily a change in configuration.